Hello, today we are going to study transverse waves on a straight string. Consider a portion APQB of a string in which transverse wave is traveling from left to right with constant velocity v. So, if we have considered this a portion APQB, this is a portion of a string in which transverse wave is traveling from left to right. It is further assumed that the string is uniform and perfectly flexible. The displacements of the strings are small and the reflections from the ends are ignored. Now here transverse wave is traveling from A to B on straight string with velocity v. So suppose now we consider a small element PQ. The wave is APQB. We are considering a small portion PQ of the wave. Let PQ be the small element of the string having length delta x. Length of this PQ, suppose it is delta x. And this angle POQ, suppose it is theta. Then we are drawing a line CO such that it bisects the angle POQ. So we will get POC equals to theta by 2 and COQ it is equals to theta by 2 that way. So now if we consider that if small m is the mass per unit length of the string, the mass of delta x segment will be m into delta x. Okay, mass per unit length in the sense capital M, suppose capital M it is the mass of the string and L is the length of the string. So capital M upon L, that will be small m mass per unit length. And if small delta x, we know that it is the length of the segment. So if we multiply m with delta x, we will get mass of delta x segment. Now as this m delta x portion is moving on circle of radius r with velocity v, the centripetal acceleration will be mv square upon r into delta x, which is directed towards center O along CO, which bisects angle POQ. So this is, this is R. So we get this CO which bisects this angle POQ, and this PQ segment, it is performing circular motion of a radius r. Now let T be the tension at P and Q, and suppose we resolve tensions in the two rectangular components, we get sum of components along CO, that is 2t sine theta by 2, and the other two cancel out. So suppose we have resolved this tension. Okay, so horizontal component is t cos theta by 2, t cos theta by 2. Now these two are acting in the opposite direction and they're equal in magnitude, so they will cancel each other. Now here when we take this, there is nothing, this is a wave, so we cannot take the portion which is above it. So we will have component 2t sine theta by 2 which is moving downward, and this 2t sine theta by 2, it is the component which is balanced by centripetal force. Centripetal force, we know that it is given by mv square upon r. So so we get resolving tension in the two rectangular components, we get sum of the components along CO equals to 2t sine theta by 2, and the other two components cancel each other as they are equal in magnitude and opposite in direction. Now since theta by 2 is small, we can consider that sine theta by 2, it is approximately equals to theta by 2, and resultant tension 2t sine theta by 2, it can be written as 2t theta by 2. If we cancel 2 over here, we will get t theta. So resultant tension is t theta, and we know that this resultant tension is balanced by the centripetal force. So at equilibrium, the resultant tension provides the necessary centripetal force. So we can write t theta equals to m delta x into v square upon r, because formula for centripetal force is mv square upon r, and we know that the mass of the segment with length delta x, this is m delta x. So m delta x, that is nothing but the m v square upon r. Now suppose theta, it is equals to delta x upon r. So we know that this is theta, it is equals to delta x arc upon length. So PQ is the equals to delta x and this length is r. So we are using that formula. So suppose theta equals to delta x upon r. So we will get t delta x upon r equals to m delta x v square upon L. So this delta x will get cancelled, r will get cancelled, and we will get v square. We can shift this t over here. So we get v square equals to t by m. Taking square root of both sides, so we get v equals to root t by m. So thus velocity of wave along a straight string, it depends upon two parameters. One is tension T in the string and second one is small m, which is mass per unit length of the string. Thank you.